All right, welcome to The Explainer. Today, we're basically going on a manhunt, but our target isn't a person. It's a microbe. We're going to crack the case on one of history's most notorious bacterial bad guys, the one that causes typhoid fever.
So the big question is, how does something you can't even see become this notorious public enemy? Well, we're going to tackle this just like a detective story. We'll be tracking the moves, the MO, of this incredibly stealthy invader.
Okay, so first things first in any investigation, right? You gotta know your target, and ours is a bacterium called Salmonella Typhi.
Now, what makes this little guy so unique is its laser focus. I mean, unlike a lot of other bacteria, this one is a human specialist. It's only interested in us. It exclusively targets people to cause this really severe illness that doesn't just, stay in your gut. Nope, it spreads throughout your entire body. And that systemic illness, that's what we call typhoid fever.
Okay, check this out. What's so fascinating is how this bacterium wears this clever disguise. It's covered in these three main things called antigens, and each one is like a different clue for the investigators, the doctors. You see that O antigen? That tells them it's likely a recent infection. The H antigen, that points to a later stage. And that VI antigen, that one's the real telltale sign that can unmask a hidden carrier.
So, how does this microscopic perp actually pull off its attack? Well, it's all about one thing: stealth.
The whole operation kicks off when someone eats or drinks something contaminated. But get this isn't some small-time raid. It takes a literal army. You'd have to swallow anywhere from 1,000 to 1,000,000 of these little rod-shaped bacteria, we call them bacilli, just to launch a successful invasion.
And here it is, the 5-step modus operandi. This is brilliant, really. It's not a direct frontal assault. First, Salmonella Typhi gets through your gut lining. Then, and this is the clever part, it gets gobbled up by our own immune cells, these cleanup crews called macrophages. But instead of getting destroyed, it uses them like a Trojan horse. It literally hitches a ride on the body's internal highway, the lymphatic system, to set up bases in places like your liver and spleen, and only then does it launch that huge secondary attack into your bloodstream.
Yeah, that hidden submarine analogy, it's perfect. It just nails how S. typhi can multiply deep inside our own defenses, totally undetected. It's only when it decides to surface and launch that big secondary attack that the body's alarm bells finally start ringing. And that is the exact moment the person actually starts to feel sick. It's wild.
All right, let's move on to the evidence left at the crime scene. We're talking about the clinical symptoms that show up once this takeover is in full swing.
So the illness follows this really specific timeline. In week 1, you get this unique stepladder fever, where it just keeps getting a little higher with each spike. Then in week 2, the high fever continues, and you might see this faint rash. They call them rose spots. But by weeks 3 and 4, wow, that's when things can get really serious. We're talking major life-threatening complications, like internal bleeding or even a tear in the intestine.
And along with that signature fever, doctors, our investigators, are looking for a whole bunch of other clues. But here's a really weird one. A slow heart rate. I mean, think about it. When you have a high fever, what happens? Your heart usually pounds, right? It races. But with typhoid, it can actually stay slow. That is such a classic, counterintuitive piece of evidence that really points fingers at this specific culprit.
But here's the thing. The story doesn't always end there, with getting better or not. Sometimes the culprit goes deep, deep into hiding. It basically creates a sleeper agent inside the body.
Yeah, that's right. In about 2 to 5% of people who don't get treated, they feel totally fine, they recover, but they become a chronic carrier. They're shedding the bacteria for more than a year without having a single symptom themselves.
And that brings us to maybe the most famous case of all, Typhoid Mary Mullen. This is the crucial point. She was a cook, and she felt perfectly healthy. She had no idea she was spreading this dangerous disease everywhere she worked. Her case was just a bombshell for public health. It was the first real proof that a completely healthy-looking person could be a walking, talking, hidden source of a massive epidemic.
So these carriers, they become these long-term reservoirs for the bacteria. And often, the bacteria sets up a permanent base of operations in the gallbladder. It forms these protective shields called biofilms, a lot of times on gallstones, which makes them incredibly difficult to get rid of.
So, with a culprit this sneaky, one that can hide inside our own cells and even hang out in people who have no symptoms, how on earth do you definitively pin it down in the lab?
Well, the trick is knowing where to look and when to look for the clues.
In that first week, your best bet is a blood culture, because the bacteria are actively circulating. A little later, you switch tactics. You start looking for antibodies in the blood serum. And then, by week 3 or 4, the culprit finally starts showing up in urine and stool samples.
And to find those antibodies, lab techs have tests like the Widal test. What they're doing is basically looking for the antibody fingerprints our bodies create to fight off those O and H antigens we talked about earlier. And if they see the level of those antibodies going up over time, that's a really strong signal that you're dealing with an active infection.
Okay, so once we've got a positive ID on our culprit, it's time to launch the counterattack. Let's talk treatment and prevention.
Getting on antibiotics quickly is our frontline defense. We've got drugs like ceftriaxone that are super effective, and there are other good options too. But the absolute #1 factor here is speed. Starting that treatment as early as possible is just vital for a good recovery.
But our investigation is getting a lot more complicated, because this is an arms race, and our culprit is evolving. Just look at this data from India. Over 70% of S. typhi strains there have figured out how to resist a whole class of really important antibiotics. That's a massive, massive challenge for public health. And that growing resistance, that's exactly why prevention is so critical. The good news is we have 2 main types of vaccines that give you pretty solid protection. There's an injection that's recommended for kids over 2, and then there's an oral vaccine, one you drink, for anyone over 6. So when you close the case file on Salmonella Typhi, you realize you're looking at a true master of stealth and survival. But the game is changing. This rise of antibiotic resistance is a real game changer, and it leaves us with this huge, critical question for the future. As this ancient enemy keeps adapting and evolving, how do our own investigations, our science, and our public health strategies have to evolve to stay one step ahead?